Any questions? No? All right. Okay, so suppose we have a pulley in the form of a solid cylinder. And we wrap it around, let's say we have two objects, one 60 kilograms and the other one 20 kilograms on the other side. And we then allow them to start moving from rest. Okay, what do you expect to happen?
Yeah, what
A and B. What's going to happen to A? A is coming down. And what about B? B goes up, and C. C is going to rotate
something up.
counterclockwise. Very good. So that's what's going to happen, right?
I swear.
Let's then
Rotate.
look for unknown. So we want to find the following. A, since it's going to accelerate, so we find the acceleration.
That's why I keep changing.
And the cylinder is going to rotate faster and faster, so we'll find the angular acceleration.
What's to see that when people make fun of when they fail at the end?
And there also would be
But I
two
have no
tensions
access to
here. So we want to find the two tensions.
They don't rotate.
Okay, now we have done this kind of problem earlier without a rotation. So let's look at A. How many forces are acting on A? Two forces. Okay. One is the gravity, M1G, and the other one is the tension T1. Between the two, which one is larger? The weight, right? The weight is going to be greater than, so you have M1G minus T1, and this is the net downward force on A. Net downward force. Okay,
You see that short
on A. So net force is equal to what? Net force is equal to MA. But this is M1, so let's put down M1A. We are given numbers, so we can put down 60 for M1. T is 9.8, okay, and 60A. So that's considering A. And how many unknowns do we have here? Two equations, but we have one equation. Two M2G. Between the two, which one is greater? T2 is greater. So we get T2 minus M2G, and this is going to be what? The net upward force, right? Okay. And the net force is equal to MA, so it's going to be equal to M2A. That's considering B. And again, let's put in the numbers that we know. M2 is 20. It's 9.8. So that's another equation that we have. Now we have two equations. How many unknowns do we have? We have three unknowns.
That's the problem.
Okay, so now we need to work on C. Okay, let's go to C. All right. C here experiences T1 and T2. The same radius. We take the axis of rotation, which is the symmetry axis, to where the force acts. Then the counterclockwise torque is T1. The clockwise torque is T2. So if we use a negative sign for the clockwise torque, then this is the net counterclockwise torque. Are we okay there?
Yep. Yep.
In this case, the angles are 90 degrees and 90 degrees. So the sine of 90 degrees is a 1, and I didn't write it down. Okay. So this is the net counterclockwise torque. Newton's second law for rotation. Net torque is equal to net force. Net force is equal to MA. Net torque is equal to what? I alpha. Right? Rotational inertia and angular acceleration. So we have I alpha. Now, the fact that we have a solid cylinder comes into play. For a solid cylinder, what is I? What's the rotational inertia? 1/2 m r squared. So that's the I. So that's 1/2 m r squared. All right. Yeah. So that's simplify this a little bit. We have R times T1 minus T2 is equal to 1/2 m r squared alpha. The R and R cancel. So you rewrite the equation as T1 minus T2 is equal to 1/2 m r alpha. Okay, so that's our third equation. We have three equations now. How many unknowns do we have? We have 4 unknowns. Very good. Okay. anytime you add an equation, you add an unknown as well. So now we need the fourth equation. Where is that fourth equation? Fourth equation is always there, and I mentioned earlier that anytime you have a rotational motion, S and the theta, the V and the omega, the A, this is the tangential, okay, tangential, and the alpha. They are related by a set of simple equations. So, in this case here, the accelerations of A and B are the same because they are tied together. Okay? So those are tangential acceleration, not radial, not centripetal. Okay? Rather it's tangential. So you have that relationship. A is equal to what? Alpha. So in other words, this here is nothing but the acceleration A. So you have this here, the half, and A.
Right.
All right. But I have used the fourth equation, which says that A is equal to R alpha. Okay, I've used that fourth equation. Just many times people forget that there's such a relationship. Okay. Any questions, comments so far? Hey, you lost me long ago. Join.
Was it a class? Yeah. Wait, what?
All right. Let's see.
And nobody raised their hand?
So that's you were not telling me that time is out of time. 60 times 9.8. 9.8 times 60. And that's 588. 588 minus T1 is equal to 60.
Alright.
Second one.
Let's just
Two
put
is
it.
98. That's 196. Okay. And that's 28. And the third
28.
equation is
Not 28,
T1
28.
minus T2 is equal to 1/2 MA. But M is what? M is 30. So 1/2 of that is 15A. Okay. So 1, 2, and 3. Okay. That. And all we have to do is solve the 3 equations for the 3 unknowns. Easiest thing to do is just add them up, right? Add them up. T1 cancel, T2 cancel, and you have 588 minus 196. Okay, so that's 392. And if you add them up on the right hand side, it's what? 8095A. So we get A right away. 392 divided by 95. 4.13. 3 meters per second. And once we have that, 4.13, the radius is 0.2 meters. Alpha, you get the 4.13 divided by 0.2. So that would be 20.63 radian per second. Okay. Keep in mind you have to use the radian mode. Okay. Don't use degrees.
I just taken it.
So once we have those, we define the 2 tangents. And the tangent 1 is going to be 88 minus 6A, 6A. So A is now known. Let's see. You're right, 68. Thank you. 68.
What?
68. Okay, 588 minus
Put that thing on
68.
your finger.
So we have A here, 4.13 times 60. And change some, add it to 588. 340.2. And T2, then be 196 plus 28. A is 4.13 times 20. And we add that to 196.
Pierce my ear.
So we 26 Newton.
Will.
All right.
I'm gonna pierce my ear.
So you have four unknowns
stapler.
and all of them are salt. Now, this is standard method using Newton's second law for rotation and for translational motion. Is the acceleration constant or not? The acceleration of 4.13 is constant acceleration, right? So this is a constant acceleration motion. And for that, if you're given the height, you can find the time it takes for A to drop to the floor, right? Are we okay? And you can find the time. And once you know the time, you know the final speed, the speed that it hit the floor with. And if you know the speed, you know the kinetic energy. You know the kinetic energy it has right before it hit. And you also know the potential energy, gravitational potential energy, MPH. You know the height. Also for B, okay, you know the initial gravitational potential energy and the final kinetic energy. Plus, C is now rotating, so it's going to have rotational kinetic energy. What's the rotational kinetic energy? Okay, what's the little formula for the rotational kinetic energy? Instead of half mv squared, we have what? Half what?
MR squared. MR squared.
Half mr squared is for rotational inertia, not kinetic energy. Half mv squared, you go half what? What corresponds to m? I. Okay, and what corresponds to v?
Got me eating almonds.
Half I omega squared. And that's the rotational kinetic energy. Right? So, one can solve this problem, let's say, stated another way. If you're given the initial height and you try to find how long it takes to drop to the floor, what the final speed is, and so on. Now that we have the acceleration, we can find the final speed.
IW squared.
But anyway, using the energy language, you can also find out. Okay, so that's just another way of looking at the same problem. All right, any questions? This is what you call the dynamics, rotational dynamics. That is, things are starting to move, and you have angular acceleration. Okay. have much time left. So test 3 would be, let's see, a week from Thursday. Let's see, if you're in the Thursday lab, okay, so, and the following Tuesday. Okay, so it's the Thursday next week and the following Tuesday. If you're the Tuesday lab. Are we okay?
Yeah.
Which day do you have?
So we have
11. Okay.
That's good.
And
Well, at least it's not on the same day as mine.
last time we had
Next chemistry
up to
test.
7, right? So we're gonna have 3. What? Eight is conservation of energy. Yeah. That's it. Ask me next time.
The 19th.
No, that's actually the first day of the class. You already know it. That's to remember, right?
It's on the final schedule.
Page, they go by the first meeting in the week.
When I said it's in the final schedule. Two people looked at turn around and
I
looked
do
at me.
it last week sometime, and then I forget. Yeah. But anyway, they always go by that schedule. That is, if your class starts what day of the week at what time, then the final
Well, that guy said that they're not even gonna have the budget for check it out. He was wrong.
What's that?
Over 15%. You have to look like that.
We have a class on.
So it does it after 100. Each test is 15%.